All right, we need to start from case number 7, regression case, where your independent variable is categorical. It means your independent variable will become categorical, having more than two categories. In the previous case, we just have the two categories, but in this case, we might be having more than two categories. So whenever your independent variable becomes or having more than two categories, the procedure is changing again uh, while your dependent variable is same as binary. So in case number 7, what we need to do is, a minute, yes. So is there any effect of age group on chronic heart disease? So what we need to do here, we need to open our data set for case number 7. That is the one. This data set might be available with you. So you need to just open case number 7 data set, and you can close the previous one. So this is case number, and we mute all. All right. So this is basically case number 7 data set, and again you need to clear these all from here because we need to create them in our situation. So what we want to know here, our concern is there any effect is there any effect of age group on chronic heart disease? So we are dealing with the age group, we are dealing with the different categories of age group on chronic heart disease. So if you can see the age group variable over here, just a minute. If we see the variable, this is the age group variable. You can see it is categorical variable. It is having 8 categories. So as it is independent variable and it has more than 2 categories, so we need to change our process. So how can we do it? Second thing, what we need to see the chronic heart disease status. So we need to find out where it is. It is the first one. This is basically the chronic heart disease status, and you can see it is binary. So as per our requirement, our independent variable would be categorical, having more than 2 categories, and our dependent variable would be binary. So in our case, the chronic heart disease is binary, while the age group is basically categorical. So in this case, what we need to do, there is a special treatment of this case. So what we need to do, when the categories of your independent variable are more than 2, then first we create a dummy variable, same as we did in case number 4. If you remember, yesterday I let you know how to create the dummy variable. So in this case, we will create the dummy variable in the same way. Since the total age groups are 8, I have told you if you need to create the dummy variables, you need to see how much categories you have. In our case, we have 8 categories. Basically, we have 8 categories of the age group. So we can create 7 dummies. It means we will consider one age group as a reference category. Then we will run the regression in the same way as we were doing the previously. So as a first step, you need to create 7 dummy variable of the age group. Then you run the binary logistic regression using the same way that we were doing, like you will be using DV as a status of heart disease and IV as a age, and establish a predictive regression model. And then you need to calculate the z value in the same way as we have done, and in our case, we are predicting the chronic heart disease. So we need to have the probability of chronic heart disease. And then we will create cluster bar charts. Again, we are creating cluster bar chart, taking the taking the age group variable on access and define cluster by PCHD, which is this variable. So one by one, I would like to let you know how the whole process will be applied. So the first step is creating 7 dummy variables because we have 8 categories. So how can we do it? If you remember my yesterday session, I have I have let you know how you can create the dummy variable. So our variable of interest is basically age group. So here are basically 8 age group. So we need to create one as a reference category. Like if we want to create 8 as a reference category, we can create 7 dummy variables. If we want to create one as a reference category, we can create remaining 8 as a dummy variable. So in case of heart disease, chronic heart disease, what is our expectation? We expect that a person having more age may have more chances of heart disease. So a person with having an age of less than 30 may have a less chances of chronic heart disease. So we should take below 30 as a reference category, and we should create these remaining 7 from category 2 to category 8 as a dummy variable. So how can we create it? We need to understand that we need to start from here. So we need to start from reference category 2. So transform button, go to the transform button and you need to recode into different variables. You go here, you select the age group as an input variable. You need to put here, you need to write here dummy hyphen. I think the category that we are entering over here, just a minute. We need to have a screenshot of all these categories so that we may comfortably create them. So you just need to have a screenshot on here. Yes, so that we can see here. So the first category is 31 to 34 age. So go here, go to the transform, go to the report into different categories and put your age group into input variable and just name it dummy, dummy age 1. We can write here dummy age 1. This is a simple one, and you need to write here dummy hyphen 1. Yes, and you need to click on the change button. It will change it. Then you need to create old and new values. And what you need to write over here, you need to see the category of dummy variable that you are applying here. So the old value of our first dummy would be 2. This is 2 is the old value. So you need to put this 2 over here as a old value. As we are basically measuring the impact of this dummy variable, so we can measure the impact using 1. You need to click add, so it will convert 2 into 1, and you need to consider all other values as a 0. So what it will do, it will basically all else 0 means that when you are creating your first dummy variable, the remaining category will become 0. So therefore we have added all other values as a 0. So it means we are creating dummy for the second category, and we have measured their impact using 1, and we have considered all other values equal to 0. So click continue and click OK, and you need to see whether the first dummy has been created. Yes, you can see over here the first dummy has been created. Then you go for the second dummy in the same way. Go to the transform, go to the recode, and you need to reset it again. put it back over here, it will appear with a question mark. Previously, it was not appearing with a question mark. Now, you need to put your second dummy. So how can you do it? You can write over here dummy age 2. Yes, you need to put here d hyphen 2. It is very simple. You need to click on the change button and it will change the name of the variable. Then you need to go to the old and new values. So what is the old value of our second dummy? The old value of our second dummy is basically 3. So we need to put here the old value, which is 3. And as we are measuring the impact of this variable, so we need to include 1 over here. Click add button and we will consider all other values as a 0. So here it is. You need to click continue button and then you need to click OK button. So you need to check over here that the second dummy has been created. This is first dummy, this is second dummy. Now we need to create the third dummy in the same way. So so go to the decode into different variable. You need to reset it. You need to put the age group again over here. You need to put the dummy and age 3. Put here d hyphen 3. You need to click change button. You need to go old and new values. You need to see what are the values of your third dummy. This is 4. Basically, the 4 is the value of the third dummy. So you need to put 4 over here. You need to put 1 over here and you need to click add. Then you need to click all other values as 0 and you need to click add, continue and OK. So it will generate your third dummy variable. So after it, you need to create the fourth one. We need to create approximately 7 dummy variable to start our next step. So be patient. We need to create these dummy variables. So again, put it age over here. And 4 t underscore 4 change old and new values. What is the new old values of fourth dummy? That is 5. So we need to put 5 over here. You need to put a 1 over here and you need to add it. Then all other values is equal to 0. You need to click add button and click continue, again OK button, and it will create your fourth dummy. Then in the same way you need to create your fifth dummy. That is, you need to reset it first, then you go to age, yes, and you need to write over here d hyphen 5. Change it, it will change here. Old value for fifth dummy is 6. You need to put here the 6 over here. You need to put a 1 over here. Click add all other values 0 and add, then click continue and then click OK. It will create your 1, 2, 3, 4, 5, fifth dummy. Now second last dummy. Go to the transform, recode different variable and reset over here. Again, go to the age group. You need to create hyphen age 6, d hyphen 6, change old and new values. What was the old value? Old value was 7. Old value was 7. New value 1. All other values 0. And this is created. and click OK. And you can see that 6 dummy has been created, and there is still a 7th dummy. What is that dummy? As we have used the first category as a reference variable, and we need to create the 7th dummy using 8th category, which is greater than 60. So we can use 8 as a number, as a old number. For this, go to the transform, recode, reset your variable, go to the age box again, you may put dummy 7 label underscore 7, sorry, a hyphen 7, change old and new values. So the old value is 8 and new value is 1. Add all other values 0. Add, click continue and click. So our first step has been completed. We have created 7 dummies of our variables. So what we need to do next? What we need to do from here? So after creating the 7 dummy variables of the age group, we need to run the binary logistic regression. DV is the status of heart disease, and IV is basically the age groups that we have created, and establish a predictive model. So how can we create it? So go to the analyze, go to regression, go to binary logistic. You just need to add your dependent variable, which is, if we see, our dependent variable is status of heart disease, chronic heart disease. So we need to put chronic heart disease as a dependent variable, CHD, and we need to put our independent variables over here like this. You don't need to change the category because you are using different variables over here. So if there is a single variable and it is having more than one categories, you can change the categorical variable, but we have created dummy variables, so we don't need to change the categories, because in case of dummy variable, we might be having 0 and 1 coding, if you can see. But if you want to consider the categorical, you might have at least 3 categories. So in this case, we have dummy variables, and in each dummy variables we have only 2 values, so we need to consider covariate only, and we doesn't need to use the categorical. So click OK. You will generate the results like this. So go to block 1, and you can see the sig value. The omnibus test model sig value is less than 0.05. So what we can conclude over here, if we see our hypothesis, is there any effect of age group on the chronic heart disease? Yes. If we see the results, we can conclude that there is an effect of age groups on chronic heart disease. So it is showing an impact. It means that your H naught is rejected. Next is Cox and Snell scare, R scare. It is indicating 24.9% variation in chronic heart disease due to different categories of age. So we can say that different categories of age basically explain the chronic heart disease status, approximately 24.9%. So next is basically the classification table, as I have told you earlier, that you need to see this value only, that is overall percentage. So it is showing that overall this model is predicting approximately 74% of our model correctly. Next is basically your variable in the equation. There are certain variables which are significant, and some of the variables which are not significant. So we need to use only those variables which are significant for our prediction model. So first of all, you need to see that your first dummy variable, which is uh, showing the first category of age, is basically insignificant. So it means that the first category of age does not have any effect on chronic heart disease. So there are 1.385% insignificant chances that the first category of age may have any influence or may increase the chronic heart disease because it is not significant. In the same way, the second category of age is also not significant. The third category of age is also not significant. So you need to interpret only those categories which have a significant value. So here there is a weak significance of category 4. In our case, we need to decide a sig value which is less than 0.05. So we may also ignore the fourth category because it is having a sig value which is greater than 0.05. So we need to go to the category 5, category 6, and category 7. So these are basically the categories which can accurately predict the chronic heart disease. So we need to understand that the fifth category of age, if we need to see what is fifth category, one, second, third, fourth, and fifth, that is 50 to 54. So the age group with 50 to 54 having a significant impact, the age group having the fifth age group having the age category of 50 to 54 may have a significant impact on chronic on having a chronic heart disease, and there are 150% chances. This is basically 1 5 and consider 0 along with it. So there are 150% chances that a person having the age of 50 to 54 years may have a chronic heart disease, and its impact are also positive. So it means with the increase in the age category, it will also increase. You can see that the age category of the ME6. What is the age category of the ME6? 1, 2, 3, 4, 5, 6. That is 55 to 59 years. So those persons who have the age category of 50 to 59 years, they have the high chance. They have approximately 292% chances of uh, having a chronic heart disease, and it is very significant because it is less than 1%. So they have high chances of having chronic heart disease. So the reference category of 7, if we'd like to see the age category of 7 here, the last one was the seventh age category. It means those having more than 60 years of age having the highest possibility of having the chronic heart disease. So they might have 360% chances of having a chronic heart disease, and it is also very significant. So this is the way you can interpret the results. Now, for the purpose of creating a predictive model, you need only those values which are basically significant. So you can see that dummy 5, dummy 6, and dummy 7, these are the variables. They might have the values less than 5%. So you need to create a predictive model. Just go to transform, go to compute variable, and you need to write here z hyphen distribution. So how can you create it? You need to write here one by one the values from dummy 5. Just a minute. Yes. All right. I need to write from dummy 5. But before it, you need to write the constant value, that is minus 2.197. So you need to put minus sign, minus 2.197. This is the value you can here see. the constant value. Then the next one you can put from dummy 5. Dummy 5 value which is less than 0.05 is 2.708. So put a positive sign, put a positive sign over here, and you need to write this value 2.708, 2.708. Then you need to put again the positive sign because there is no negative sign again. You need to put 3.376, 3.376. Again you need to put a positive sign because the next one also have a positive value, 3.584, 3.584. uh, so this model is complete, but you need to put your independent variable. So how can you do it? You just need to use steric sign, and you need to put the age group as an independent variable because there are a lot of variable over here as a dummy variable. But there is another solution that we can provide over here. We can place the values of individual coefficient along with their dummy variable. So how can we do it? 2.708 is the value for dummy 5. So what we can do, we can add here the steric sign. 2.708 is the value of dummy 5. So we can double click the dummy 5 over here. Then we go to the next value 3.376, and we can create a steric sign over here, and we can double click dummy 6, and then we go to the next, that is 3.5. It is for dummy 7. We click here with the steric sign, and we can double click the dummy 7, and this is how you can create the predictive model. So you just need to click OK, and you need to see that your Z distribution has been created, and you can verify the value of Z distribution from here. Yes, this one. So as a second step, what we will do, we will create a negative Z. So again, we can go over here, we go to the transform, compute variable, and we need to reset it. We negative hyphen Z, and we can put a negative sign over here. We can create Z by double clicking and click OK, and you can see the value here. Z negative has been created. Then as a third step, what we need to do, we need to create exponent of negative Z. Exponent of negative Z. So how can we create it? Go to the transform button, compute variable. You need to reset it over here, and exponent negative Z. So exp start. You double click over here, that is close. You need to click OK button, and you will create a value like this, exponent. And 1 plus exponent is the second step. Yes, this one. So you go here, you go to the transform, compute variable, reset, and then one hyphen, you can put it over here, one, double click exponent negative Z, click OK, and you will create like this, one exponent. And as a last step, what we need to do, we need to create probability of chronic heart disease, that is PCHD. by reciprocal of the previous step. So go to the transform, go to the compute variable, reset it, and probability of having chronic heart disease. Chronic heart disease. You need to go S1 slash 1 exponent. That is the reciprocal of your previous step. You need to click OK, and you will create the probability of having a chronic heart disease. So you can see here, uh, you can see here the value of there are different percentages. You can see like 10%, 63%, 76%, and so on. There are different chances of having a chronic heart disease. So as a third step, what we need to do, if you can see, as a third step, create cluster bar chart using take age group as a variable on axis and define cluster by PCHD. So we need to create a cluster bar chart. So go to the graph, go to the legacy dialog box, and go to the bar. And you need to select the cluster bar charts. You need to put the age group here in the category axis, and you need to put probability of chronic heart disease in defined by cluster, and then you need to click OK button, and you will find results like this. This is basically the probability of having the chronic heart disease. You can see that there are more person with the age category of 50 to 59 who may have high chances of having chronic heart disease, and uh, the second one who may have chronic heart disease from the age category of 50 to 54 years. So basically, these are the three who have significantly, they may be significantly influencing, while the remaining categories like below 30, 31 to 34, 35 to 39, 40 to 44, and 45 to 49 are the categories who have the insignificant results. If you see the results previously, you can see like dummy variable 1, dummy variable 2, dummy variable 3, dummy variable 4, uh, up to dummy variable 4. These are the categories who have the insignificant impact. But dummy variable 5, 6, and 7, they were the last three categories who are having the significant impact. So those with less than 10% chances of having the chronic heart disease are indicated by blue bars, and those with having more than 10% chances of having chronic heart diseases is basically indicated by the colorful bar charts. So this is how you can interpret the results. So this was our case number 7. So we are moving towards the case number 8. That is basically the case of multinomial regression analysis. So if you have any question, you may ask, or we can proceed further towards the case number 8, because we still have 3 more cases to resolve. So if you have time, please let me know. Can we proceed further, or may you have any question you may ask? And these cases would not take more time because we don't have to create any dummy variable or any category. We just need to do the simple analysis in these categories. So we may be needed another session of 40 minutes to complete these 3 cases. So if you have any question, you may ask, or you want to ask something, or you may comment on these cases. You may ask. Please let me know if you have any question, or can we proceed further? All right. Thank you, Evelyn. We may proceed further towards case number 8, and let me open the data set for case number 8, 9, or 10. There is a single data set that you can use for case number 8 9 and 10, which is regression 8 to 10 data set. You should open this data set so that we may analyze it in three different situations. And after opening it, in the meanwhile, we can read the situation that is provided over here. The data set is opened, but we need to understand some initial information over here. So in this case, your dependent variable would be categorical. It means your dependent variable might be having more than two categories. In binary logistic, your dependent variable might be having only two categories. That is why that is called the binary logistic regression. But in this case, whenever your DV is having more than two categories, it will become the case of multinomial regression model. So you need to understand the difference and you need to understand the process. So your independent variable in case number 8 is quantitative. Your dependent variable is categorical. So we are interested to know, is there any impact of salary on breakfast preference? Salary is basically the quantitative variable, while the breakfast preference, like you like to take cereal, oatmeal and breakfast bar, which type of breakfast preference do you have from these three? So this is categorical variable because you are having three different categories and you are having salary as a quantitative independent variable. So our null hypothesis is there is no impact of salary on breakfast preference, while our alternative hypothesis is this there is an impact of salary on breakfast preference. So in this case, we have three categories independent variables. So while running the model first, we have to set the reference category, whether we are wanting the first to be the reference category or we wanting to the last to be reference category, because we have three categories in our dependent variable. So we need to take one of them, either the first or the last, as a reference category. Further, our independent variable is quantitative, therefore we will add it in covariates. All right. So what we need to do is, just a minute. What we need to do is you need to go your regression model. There is basically less than 1 minute. So let's wait to the meeting to end it. And please join again because these three cases are very much interesting cases and you need to learn this. So please join again using the same link so that we can start from the case number 8, how to analyze it and complete our session with these three cases. So join again from uh, by using the same link. It is going to end. Yes, it is.